YouTube channel, and I'm here again to discuss or answer the chapters activities in netacad.com. So we have here the um, chapter 7 activities. So this is the first activity that we need to do, the binary to decimal conversion activity. So instructions. This activity allows you to practice 8-bit binary decimal conversion as much as necessary. We recommend that you work with this tool until you able to conversion without error. Convert a binary number into octet to its decimal value. So first we have here the decimal value, the base, the exponent, the position, and the bit. So we need to enter the decimal value. So for us to identify what is the decimal value, all we need is to all that have a 1 here in the bit, the 0, 1, 0, 0, 1, 0, 1, 1. The all have a 1 mark is we need to add 64 plus 16. So we need to add 64 plus 16 plus 8 plus 1 plus plus 2 plus 1. So the answer is 235. So we're going to check it incorrect. So we have to try a new number. We have to try a new number for us to be mastered with this kind of what kind of a binary to decimal conversion. So we have here the 128 plus 4 plus 2 plus 1. So we have here, so we are going to recheck if it is correct. So we have here the 128. So I'm using calculator for us to easily solve the problem. Plus 4 plus 2 plus 1, so equals 135. So the answer is 135. So we're going to check if it is correct. So the answer will be correct. So let's move on to our next activity. So for our second activity, we have here the decimal to binary. So we have here the given 85, the decimal value, and we're going to find what are the bits. So first, to get the bit, all we need is to subtract this decimal value to the position. So the 85 cannot be subtracted by 128. So the answer is 0. And 85 can be subtracted by 64. So We have here the 85 minus 64 equals 21. So 32 cannot be subtracted to 21, so the answer is 0. And this 21 minus 16, this will be 1, because 21 minus 16 is 5. So 5 minus 8, 0, and 5 minus 4 is 1. So the answer here is 1. 1 minus 2, 0, and 1 minus 1 equals 1. So let's find if it is correct. Check. So we successfully answer, and we have. So this is our third activity that called the binary game. So I have rotated my screens because the game requesting to rotate the screen into a portrait mode. So without further ado, let's start this game. So this game is very easy. So the answer would be 32, and the answer would be this 248. So we're going to use the calculator for us to um, resolve this faster. So 128. So this is not this. So 128 plus 32 plus 16 plus uh, we have here the 2 and 36 equals 32. So here 35, 32 plus 32 plus 2, then 255, 120, and the answer here is 64. So um so this game will be practicing you how to convert decimal to binary and binary to decimal. So here we have to answer this 6 4 5 7 4. So 128, 128 to 55. So this game would help you a lot to practice the conversion of this decimal to binary and binary to decimal. So we have to proceed to our next activity. So guys, for our next activity, we have here the activity ending to determine the network address binary and the network address in decimal. So first we have here um, the um, uh, the host address binary. So if the always have by 0, the answer here in network address binary is 0. So here we have 0010. So we have this activity is very easy. It is a refreshing activity. So second we have 01 011 000. So as you can see, this is all zero here in subnet mask in binary, so the answer will be 0000. Next we have to answer the decimal. So the decimal of this is the 124,810. 108 plus 2 is equals to 10. 64 plus 16 plus 8 equals to 88. Then this will be all 0 because the binary is 0. So I'm going to check if it is correct. So check correct. We have successfully answered this activity. So we are here at the activity unicast, broadcast, or multicast. So instruction: click start to view a destination IP address. Next, click host, which are received by packet-based address type unicast, broadcast, multicast. This is a time activity, so we have a limited time here, which is 10 seconds. So we're going to start this one. This is a multicast. So 192.37192.126.17. So correct. Let's try another one. So this is also a multicast. 1237192.126.17 equals to a multicast. So let's start again. This is a unicast, multicast, or broadcast. 255.5.77126. This activity is basic. So like the other 123.7.192.126.17 is a multicast. So in this activity, we're going to practice the unicast, broadcast, or the multicast, identifying destination address. So again, we have to start this. So for our next activity, we have here the activity pass or block IPv4 address. So instruction: decided to pass or block each IP address depending on whether it is public internet and a private small local network. Click start to begin and click either pass or block. So we know that we have IP addresses that public and in private. So let's try this activity. So this is pass. This is pass. I'll say pass. Oh, it's wrong. Pass and block. Pass. And this is also a pass. So we've done this activity. This is a very easy activity, but I can explain the whole activity because to identify what is public and the private, because the game is so fast and the game giving a IP address very fast. There's a limited time. So overall, we successfully answered this activity. we have here the activity, public or private IPv4 address. So in this activity, we're going to identify if the IP address is private or public. So let's start this. So this 172.16.35.2 is in private because of the 172. This is also a public. Wait, no, this is also a private because of the, this is public because of the 209 is not in the, and the this is in a public. This is here. So going to check if it is correct. So correct, we have successfully correctly identified all the IP address in this activity. So in this activity, you can easily identify what is the public and the private um, IPv4 address. This would be a classified into public and into private. So for our next activity, we have here the IPv4 issues and solutions. So instruction, drag the IPv4 and the IPv6 terms, the field next to the appropriate description. So we have here the description, 128-bit address and 340 and decillion addresses. So the Internet Protocol version 6 is the answer to this because the Internet Protocol version 6 is the more higher and efficient address than the IPv4, the Internet Protocol version 4. So this is the IPv4, 32-bit addresses with 4.3 billion addresses. Second is the transport an IPv6 packet over IPv4. So from the word transports, this is the tunneling. So uses N86 for convert between IPv4s or IPv6 and IPv4. So this is translation because of the word convert. Then the last is the dual stack, allows IPv4 and IPv6 to coexist in the same network segment. So we're going to check. So correct, we've successfully convert or match the IPv4 and IPv6 to their descriptions. So in this activity, we try to answer or to find the issues and the solution in the Internet Protocol version 4. So in this activity, I think it's the 8th activity. So we have here the practicing IPv6 address representation. So we have here the omit the leading zeros and the compress format. So we're going here to compress. So we have here the 2001 0, the B8, it's capital B. So here 111 and 0 0 0 and here the 200. So we have here the compressed format, which is 2001.0 DB8 111 then 2 colon and 200. So we're going to check if it is correct. So correct. So we have here the second figure. Oh, we have here the second figure. Going to the second figure, the 213 0 1 2 3 4 5 6 7 8 9 A B C D E F 0 0 0. This is only 1 0, and this is 1. So we need to compress. We have D 2 1 2 0 1 3 0 1 2 3 4 5 6 7 and 8 9 AB and C D E F. Cause 1. I think this is the way. Yan. Correct. So I'm heading to our third figure. So we have here 10 figures. So we are now in we have here in 10 figure, and we are now in third figure. So we have here 0 0 0 0 0 0. So the answer this in compressed format is, I think this, let's check if it is correct. So this is wrong. So we're going to compress this. So we are having a problem. So we need to answer this again with 0 0 0 0 0 0. I'm having a bit typographical error because I am using only a mobile phone. 0 0 and 1. So this is going to be the double colon and 1. So check. Okay, we successfully correct this, and we're going to our fourth figure. Going to our fourth figure. So we are here at the fourth figure, so we're going to answer this. 2 1 2 A B C D E F 0 1 2 3 4 5 6 7 8 9 1 0 and A B B B. So here at our we have to enter compressed format. This would take so long. We have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, AAA, and BBB. So correct. So we are now going to chapter the figure 5, which is AB 1E, the 2B, AB1E, colon, 2B00, then 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 0, 1, 1, 1, 2, and 1, 1, 3. So we have a error. The error is we don't have a colon here. So go and check if it is already correct. So AB, A2B, 0, 0, 1, 2, 3, 4, and this would be correct. Figure 6, BB, 2B. Have here BB, 2B, EF, 12, BFF, 3, 9, 1, 2, 5, 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, and 1, 0, 1. Compressed format is the BB, 2B, EF, 12, BFF, 3, the next is the 9, BFF, 3, 9, 1, 2, 5, and then 1, 1, 1, 1, 1, 0, 1, and 1, 1, 1, 1. 101. Correct. Proceed to our 7th activity, 7 figure. So we have here 1129, 1984, 2233, 4455, 6677, 00, and 101. The compressed format would be 1129 slash 1984 dash colon 2233 4455 6677 double colon and 101. So heading to our 8 figure. 8 figure 111 0 0 0 0 0 0 101 and 1111. Compressed format 11 111 101 111. Next figure 1031 1976 1 2 3 4 0 101. So we have here 1031 slash 1976 1 2 3 4 101. Oh, it is incorrect. In 761234 0 101. And for our 10 figure we have here 0 0 0 0 1 2 3 4 6 6 7 8 9 1 0 1 0 3 4 AB. So we have here 1 2 3 4. Let me try this. I am not sure with my answer here at figure number 10. So 9101 0 and 3 4 EB. I'm correct. So this is a very long activity. This is a process of practicing in this compressing format and omit leading zeros. So in this chapter we have to practice this configuration. So we have to type the here interface gigabit Ethernet 0/0 enter, and next we have to type IPv6 address 2001 colon DB8 ACAD, and next would be now shutdown to now shutdown interface gigabit ethernet 0/1 and the IPv6 address again the 2001 DB8 ACD in 164, then the interface serial 0/0/0, the IPv6 address 2001 DB8 ACD 3164 failed successfully, and we're going to find the other one. We have here the configuration. Enter the command that will display a brief summary of the IP interface status, IPv6 interface status. So, going to type this IPv6 brief, the EC2 and successfully verified the IPv6 address configuration. So this activity practice are verifying IPv6 address configuration.